It is seldom in creating my video lessons I have the opportunity to do something that I haven't seen done on YouTube before, but this is one such instance. Run across this implicit differentiation problem. Find the points at which the graph of x squared plus 4y squared minus 4x plus 16y plus 4 equals 0 has a vertical and horizontal tangent line. So what we're going to do is find those points which are going to trace the outlines of the shape of an ellipse. First thing we're going to do is implicitly differentiate this equation, and this we do by taking this x squared, whose differentiation is going to be 2x, and then 4y squared, which is going to be 8y, y prime, and the derivative implicitly of negative 4x is going to be minus 4, and then for 16y we're going to have plus 16 y prime, and the derivative of 4 is 0, and likewise 0 on the right is 0. So now we have all our terms implicitly differentiated, and we're going to collect all the terms with y prime on the left side and move the other terms over to the right side. So we have left 8y y prime plus 16 y prime, and that's going to be equal to, we have that negative 4, move that to the other side of the equal sign, is going to be positive 4, and the 2x is going to be minus 2x. And now factoring out the y prime, we have y prime times quantity 8y plus 16, and that's going to be equal to 4 minus 2x. And now dividing by 8y plus 16, we are left with y prime equals 4 minus 2x over 8y plus 16. Now, to further simplify, we have both the numerator and denominator a common factor of 2, so we're going to divide both the numerator and the denominator by 2. And in so doing, what we have is in the numerator 2 minus x, and in the denominator we have 4y plus 8. And now we're prepared to find where we have horizontal tangent lines by taking that numerator 2 minus x and setting it equal to 0. So we're going to say find points of horizontal tangent lines. Or you can call them points of tangency. But to do that, we're going to set that numerator equal to 0. So 2 minus x is equal to 0. So x equals 2. That's going to be our x value where we have our points of tangency. And now substituting into the original equation, we have in the place of x for x squared, we have 2 squared plus 4y squared minus 4 times 2 for 4x plus 16y plus 4, they're all equal to 0. And what's going to happen is we have 4 plus 4y squared minus 8 plus 16y plus 4 is equal to 0. And collecting the constant terms, 4 minus 8 plus 4 all cancel to be 0. So what we have left is y squared or 4y squared plus 16y are equal to 0, and factoring out our common factor, 4y times quantity y plus 4 are equal to 0. So y is equal to 0, and also y is equal to negative 4. So our points of horizontal tangent lines are going to be 2, 0, and also 2, negative 4. So next we're going to find here at the right, find points of vertical tangent lines. And to do that, we're going to take that denominator and set it equal to 0. So we take 4y plus 8 and set that equal to 0. And factoring out a 4, we have 4 times quantity y plus 2 are equal to 0. So what we have is y is equal to negative 2. And now we plug y equals negative 2 into our original equation. So we have x squared plus 4, and in place of y we put negative 2 squared minus 4x, and then we have plus 16 times negative 2 plus 4 is equal to 0. And next that gives us x squared, and 4 times negative 2 squared is going to be plus 16, and then we have minus 4x, and we have minus 32 plus 4 is equal to 0. And next, collecting our constant terms, we have 16 minus 32, which is going to be negative 16, plus 4 is negative 12. So we're left with x squared minus 4x minus 12 are equal to 0. And factoring that quadratic trinomial, we get quantity x minus 6 times quantity x plus 2 are equal to 0. So what we have is x is equal to negative 6, and also x is equal to positive 6. I meant to say x is equal 6, and also x equals negative 2. And so these points of vertical tangency are going to be 6, negative 2, and also negative 2, negative 2. And so now we can sketch out the outlines of our ellipse. We go to the next page and we see these points right here. We have at the left negative 2, negative 2. On the right we have the point 6, negative 2. At the top we have the coordinate pair 2, 0, and at the bottom of the ellipse we have 2, negative 4. And so the outline of the ellipse is going to look something like this. It's going to kind of be hard to draw it neatly freehand, but something like this. That's about as well as I can make it here. And then, so I thought that was pretty neat. I hadn't seen it done elsewhere. And then on the next page, what I've done is worked out by completing the square for both the x's and the y's, what a, b, h, and k are, and graphed in the TI-84CE graphing calculator. It's going to look like this. So we see everything in place. So I thought this was a helpful approach to this type of problem, one I hadn't seen before. Good luck, and as always, thanks for viewing.